All right, well, thanks for attending. I'm Casey Stuht. Presentation is titled The Las Vegas Metropolitan Area Urban Sprawl Assessment Using Shannon's Entropy Method. So what is urban sprawl? If you ask 10 people, you'll probably get 10 different answers. Here are a few concise definitions just to lay a foundation. Unplanned urban growth, a scattering of new developments on isolated tracts separated by other areas of vacant land along the lines of a leapfrog effect, and pithy as discontinuous development. How does this happen? Many researchers by the mid-20th century held the belief that the private automobile was the main culprit for sprawl or rapid urbanization, especially here in the United States. The advancement of the interstate system led way to a leapfrog type development with vacant land being filled in over time. And below is morphology of, I think it's Baltimore, and ABC is the main mode of transportation. So late 19th century, early 20th century, and then automobile by the 1930s. And why monitor this phenomenon without getting too philosophical or diving into the cultural impacts of urban morphology? From a practical matter, through the study of sprawl or urbanization, past and present, we or those responsible for making decisions can learn what works and what doesn't work. A common theme in the study of this phenomenon is resource preservation and management. So here is the study area. It's 900 square miles. These are two images that I used, 2000 and the year 2020, and these are DBSI, dry bare soil index, which are good for showing development in an arid setting like Las Vegas. A familiar aspect of sprawl is that it is first noticed on the peripheral or the fringe. This is shown in dry bare soil index, like I said, as it's effective in highlighting developed areas and arid regions. And yes, if you look, especially the Southwest, we'll get into that later, but that was the space to buy land in the year 2000. So as for the entropy portion, the background in a geographic sense, Richard Thomas suggests it measures the degree of spatial concentration or dispersion of a geographic variable. Next slide is the methodology or framework, and you'll see that when used in concert with satellite imagery and the GIS, it's accessible, effective means of measuring the degree of sprawl. Here's the basic methodology for the study. Landsat 7 and 8 images were corrected. Land cover classification utilized USGS level 1 land cover classes in conjunction with the support vector machine supervised learning model. These classes were broken down into developed and undeveloped. And in a desert like Las Vegas, it's basically indigenous landscape and non-indigenous landscape. So a golf course would be considered developed. 500 ground truthing points were used for both years 2000 and 2020 with accuracy assessment kappa scores of 0.86 and 0.90 respectively, meaning signature and control samples had a high level of agreement. Moving on to the second portion, starting with the multi-ring buffer zones. Entropy can utilize zones or regions, thus multi-ring buffers at 1 mile increments using, seen lower left, the concept of concentric zonation, or the city center as the center of the urban core, and upper right, based on a previously mentioned theory that the automobile and highway are major culprits of urbanization, and all those buffers are 1 mile increments. The city center, lower left, is 18 buffer zone, and top right, the highway, is 5 buffer zones. You'll notice in these images also the binary land cover scheme developed in dark blue and undeveloped in beige. Upper right, highways I-15, I-215, and US 95 have been used. They existed in year 2000 and 2020. So here's my math hat put on. This is the expression used for Shannon's entropy developed by Claude Shannon in 1948. At first glance, there's the Greek sigma symbol, which scares a lot of people, I guess, but here it means summarize. Therefore, this expression calls for two summations total. Looking first at expression B, xi, or observations, is quantity of the developed variable found in each buffer. Observations xi must be expressed as proportions pi by dividing each observation by the sum of all observations. The I basically in math stands for imaginary number. So once observations are expressed as proportions, they are plugged into expression A, which again is summation. The n above sigma represents a total number of buffers, and the imaginary I below is the particular zone being analyzed. Entropy is found via the logarithm base 10 or the decadic logarithm. So if you're still with me, so table A, and this is directly from this study. The developed land cover is the spatial variable in focus. So for each buffer, the proportion of developed land is found as developed pixels divided by total pixels. Looking at B, this proportion value is taken for each zone and summed, which becomes the divisor in which each buffer value becomes the dividend in C. For example, buffer zone 1 is 0.5794 divided by 1.6175, which results in the italicized P value of 0.358 in table D. Now 0.358 is plugged into expression using log base 10, and these 5 buffer zones are summed to 0.6278 shown in E. This is the Shannon's entropy value, or SE. To normalize SE to relative entropy, RE, or on a scale of 0 to 1, 0 being max concentration and 1 being max dispersion, CF, RE is the ratio between observed entropy of proportions and max possible entropy. So the value 0.898 in F means that within the study area, the degree that is developed spatial variable is dispersed at 90% of max possible. So for each analysis, City Hall and Freeway, years 2000 and year 2020, this was the method used to describe and compare differences in dispersion between sets of proportions. So for the direct results of this study in Las Vegas, the threshold of whether RE is concentrated or dispersed on a scale of 0 to 1 is 0.5, right in the middle. And looking at the City Hall analysis with 18 one mile buffer zones, year 2000 had RE of 88% of max dispersion, and in 2020 it was 92%. For the freeway analysis, RE was 87% of max dispersion, and in 2020, 90%. And below, you can see the change temporally over those 20-year periods. Both analyses reveal a small increase during the 20-year study period, which indicates a slight, though insignificant, increased rate of spatial dispersion. Here are scatter plots of the two analyses. The developed spatial variable is dispersed where sprawl is present. Here are two developed density scatter plots which deal with proportions within each buffer. A casual glance will notice that once vacant land was filled in over the 20-year period, further from the nearest freeway or from City Hall, the urban core. And looking City Hall analysis on left, it's important to note that the urban core changed little due to a host of factors. Casual glance, it looked like demolition, construction, revitalization, but you can see how the areas just kind of moved out. I equate it to like a growing valley, something like that. Finally, a quadrant analysis was done using a fishnet and zonal statistics. Again, it starts with pixel counting. There are many ways of gauging directional growth. I didn't really have time to get into fractal analysis, fractal geometry, but maybe next time. This type of analysis may help better focus on or position resources, as the change can be seen visually. Developed land cover grew by 40% in the northwest quadrant and by 94%, or nearly double, in the southwest quadrant over the 20-year period. This roughly equates to 20,000 and 60,000 acres, respectively. In conclusion, results of both analyses reveal that the spatial variable, the developed land cover, is dispersed across the study area, which means sprawl is present using this particular metric. Dispersion increased over the 20-year period, though not significantly. And using this metric, sprawl creeps towards increased dispersion. The northwest and southwest portions of the study area were the quadrants to buy land in 2000, as they had the greatest changeover from undeveloped to developed. To discuss, there are many definitions of sprawl, and there are many ways to measure the phenomenon. This analysis focused on one metric, Shannon's entropy, which again measures concentration or dispersion of a spatial variable. Using this metric is on a case-by-case basis, as cities in the US are prime beneficiaries, though entropy calculations of some world cities provide mixed results. This framework is cost-effective, accessible, and expeditious. It can help individuals, stakeholders, and municipalities better plan the future of their urban environments. Sprawl can affect mental health, pollution, and resource consumption. Thus, it is important to understand and recognize when considering the sustainability and prosperity of a population. That is all I have at this time. Thank you very much.